All right, let's see if we can. Here we go. Okay, so the tangent curve, let's start. I've already sort of given you the heads up that it's totally different, right? It's its own beast. So let's see if we can't figure out why is it so different. Let's think about our unit circle. Let's think about our tangent values. At 0, our tangent value is 0, okay? At our first angle, which is pi over 6, our tangent value is 1 over root 3. At our next angle, which is pi over 4, our tangent value is 1. At our next angle, which is pi over 3, our tangent value is root 3. And then what happens when we get here? It's undefined. Okay, so if I ask you to graph that point, right? So I want you to graph the point pi over 2 on the x-axis and undefined on the y-axis. Do you know how to graph an undefined point? No. So that's one of the things that makes tangent a little bit weird, is we have this break in the function. Okay, now if we put in the other quadrants, we will see some repeated values, but they are negative. Okay, so we have the 1 over root 3 that's negative, we've got the negative 1, and we've got the negative root 3, and undefined. So first off, to deal with the undefined situation, it's one of my favorite math words. We are going to have an asymptote, except you don't actually say the P. I have to say it in my head every time I spell it because there's this stupid silent P. All right, so it's really called an asymptote. And an asymptote is how we identify an undefined location on a curve. So an asymptote is sort of going to be like a break, a line, if you will. So we're going to have a break in the function. And we need to include, when we graph this, we need to include all 3 positive tangent values. We need to include all 3 negative tangent values. We need to include the 0, and we need to include the undefined. Now, we get to choose where this happens. And if I go from here through quadrant 1 and then into quadrant 2, notice how it gets broken halfway through. It gets broken by our undefined value halfway through. So I might not actually want to do all the angles in quadrant 1 and then all the angles in quadrant 2. I might not want to do that. Instead, what I'd really like to do is, what if I did all of the angles in quadrant 1, but then all of the angles in quadrant 3? Would that give me all my positive tangent values and all my negative tangent values? And the 0 and the undefineds? Okay, awesome. Well, then let's do that, because that's just a little bit easier. Now, if you come over to, let's think about our number line here. So if I'm going to do Q1, I'm going to have a portion of a graph here, and then what? A portion of a graph over here? Isn't that kind of weird? Yeah. Okay, but what if I go backwards into negative angles? If I call these angles from 0 down to negative pi over 2, if I use those, aren't those the ones that exist right here in quadrant 4? But instead of calling them 270 to 360, let's call them 0 to negative 90. And that's why the negative angles are valuable to us, because now we can start our graph at 0, we can go a little bit to the left and a little bit to the right. So that's one of the unique things about tangent. The tangent curve, we will have it start at negative 90 degrees, and we will have it continue to 90 when we graph it. So it gets split. There's a little bit of it in negative angles and a little bit of it in positive angles. And then it does repeat itself over and over and over. All right, so let's build a t-table here, and actually, so we can see what this thing actually looks like. All right, we know that we're going to go from negative pi over 2 to positive pi over 2. And we know that at those values, it is undefined. So what that's going to look like is I'm going to put a point out here, negative pi over 2, and I'm going to put a point out here, pi over 2. We are going to put a dashed line. That dashed line is how we indicate an asymptote. Now, if you were to graph tangent on your calculator, the calculator would not graph a dashed line, a vertical dashed line. But we do that to indicate where the function breaks and then starts to repeat again. Yeah, Alex?
So isn't the regular period always just pi instead of 2 pi?
Excellent point. Okay, so this distance, we saw with sine and cosine that the distance it took to do one full cycle was 2 pi. In this case, it's only a length of pi. So that is another difference with tangent. So the period is pi. So since I'm on that point, remember that equation for figuring out the b value? It's going to change a little bit. It's going to be pi over b, not 2 pi over b. All right, so let's finish with this t-table. The point that's halfway between negative pi over 2 and pi over 2 is 0. Its tangent value is 0, so that's a nice easy point to plot. Now, I want to pick at least one other point in between, and we get to choose. So what's the easiest tangent value? Trevor?
Pi over 4.
Bingo. Let's choose pi over 4 and negative pi over 4. And we're going to get a negative 1 there and a positive 1 there. So when we go to plot those, we will have a point up here. Oops, that should be a 4. We will have a point up there. At negative pi over 4, we will have a point down here. And our curve kind of looks like a cubic. If I had to relate it to something, it kind of goes kind of up and curvy through these points and then points up and down like that. The things that are important when you're graphing the tangent curve. It's important to identify the 5 points on the x-axis. Okay. Those will change if you have something right here with the x. It is important to identify the 3 values on the y-axis. Those could be impacted from a number in the front or a number sort of added or subtracted at the end. All right, so let's give this a go. Let's look at some of the graphs. One teacherly piece of advice here would be to go ahead and draw in the asymptotes. I really think it's going to help because when you draw those in, you'll be able to see how far apart they are, and that will help you find the period value. So let's see. This has an arrow up. This has an arrow down. This would have an arrow down. So I think this asymptote is right here at pi, because it's kind of right half smack dab between the 2 arrows, the up arrow and the down arrow. Now, if I go over on the other side, this one's going up, this is coming down. Halfway in between is right there. Then let's draw in our midline. There's always going to be 3 points that we have to graph, so the middle point is where the midline would be. And in this case, it did go down 1. All right, now the period length, the middle is at 0. It goes pi to the left and pi to the right. So the period is 2 pi. Is that what it normally is? Not for tangent, so this one did change. It changed by a factor of 2. So you could start kind of thinking about that. We could go ahead and use our formula. P is equal to pi over b. What we need is the b. Okay, so I'm going to have 2 pi is equal to pi over b. So what would b have to be so that this works out? No, remember, tangent has a different period length. Okay, if mental mathing this is just confusing you, remember cross multiplying always works. Pi equals 2 pi times b. So what does b have to be? Divided by the 2 pi, half. Right? Pi divided by 2 pi, the pi's cancel. So 1/2 is equal to b. So here's what I know so far. Tangent is half of theta. Okay, so look, it changed by a factor of 2, but it's stretched by a factor of 2. So this is always the opposite operation. Okay. Yes?
Could you write it as theta over 2?
Yes, you could. Let's put in the -1 at the end. And then there's one more thing we need to look for, which is the amplitude. Like, did the amplitude get stretched at all? And notice from the middle point, when we went up to the next point, that's where we would figure out our amplitude, is how far up was that next point. It was only up a distance of 1, so, you know, I would have a 1 right there. And that would be my equation. This equation will always work for finding b, but just remember that it changes. It's a different equation for tangent. All right, let's try another one. Let's see, asymptotes. Here's an arrow up, here's an arrow down, arrow up, arrow down, arrow up, arrow down. Okay, there's multiple cycles here. You just need to choose one of them. It doesn't really matter which one. We usually choose the one that's closest to the origin. So this one probably. So I think the asymptote is right here at pi over 2 and right over here at negative pi over 2. So the period length is pi, which is unchanged from the parent. So I know this much. I don't have a multiplier with that theta. All right, the midline looks like it went up 2. So I can put a +2 right there. And then lastly, let's see about our amplitude. Now, notice this one doesn't have the 3 points plotted. If they're not plotted, it's going to be up to you to read the graph carefully. So read it and go, okay, I need to find a place halfway between this point and this asymptote. And that point is right there where the curve hits that midpoint. And then over here, halfway between, the curve hits it right here. So it looks like the amplitude is really just a 1, but it's negative. It's going to be a -1 because it got flipped. Notice like this curvature right here has sort of a negative slope. And that's how you would know that that would be a negative amplitude. All right, so let's see about this one. Arrow down, arrow up, arrow up, arrow down. So here's my asymptote. Here's my other one. Awesome. That doesn't seem to have changed. Negative pi over 2 to pi over 2. So that period length is pi. So that's unchanged. So I know that there is no multiplier on my theta. The midline, let's see. There's my middle point. It's still at 0. So I don't have to add anything up or down. And let's see about our amplitude. Let's see. Halfway between brings us to this point. Halfway between, find where the curve meets it, is right there. This amplitude is 2. So this got stretched because it went up and down 2 from the middle point. So that you would put a 2 right there. And that would be it. Okay, so when you're doing the ones where you're getting the equations from the picture, do yourself a favor, draw in the asymptotes, draw in the midline. It will really help the pieces sort of fall together easier. All right. right, so let's do some graphing. In this case, that is going to be our new midline. And any number attached to the theta would give us an x-axis change. In this case, it's just a 1. So my period is just pi. Because remember, period is pi divided by b. So therefore, it's just pi. All right, so my tick marks are going to be exactly the same as the parent, pi over 4, pi over 2, negative pi over 4, negative pi over 2. Put in that asymptote on either end. Now, our midline is going to be right here. So there's your center point. The amplitude is just a 1. So from here, I go up 1 and down 1. And then we just draw our curvy little shape. And just do your best. It basically approaches that asymptote, but never ever touches it and never ever crosses it. It just gets really, really, really close to it on both ends. There we are. This one has an amplitude change and a flip. So midline did not change, period did not change, but this is flipped and stretched. All right, so these points are the normal points, pi over 4, pi over 2, negative pi over 4, negative pi over 2. But now we're going to go up to 2 and down to negative 2. Asymptote, asymptote. Now, since it got flipped, when I go to the right, I'm going to go down. And when I go to the left, I'm going to go up. And there's your curve. Easy peasy? Awesome. I think our last one is definitely going to be the hardest. Now, why is this one harder? It's changing the x. It's an x change. So therefore, all of your tick marks on your x-axis will change. So this right here is your b value. B is 1/3. Now, does anybody have an idea of like what's happening here? Did it stretch or did it shrink? It stretched by a factor of 3. Awesome. So this is a stretch by a factor of 3. If you can get yourself through that logical conclusion, it will make it a lot easier. Here's why. Well, we know this didn't change and the period did change. So let's think about that. If it was normally pi, but it got stretched by a factor of 3, what would it be?
3 pi.
3 pi. Look at how easy that was. Now, you could use the formula if you wanted to, right? P is equal to pi divided by b. So then P would be pi divided by 1/3. Dividing by 1/3 is the same as multiplying by 3. Okay? So you could go ahead and use the formula, but sometimes logic is faster. The other thing that can be tricky at times is getting those tick marks. So start by writing down your original points. All right, so your original points were negative pi over 2, negative pi over 4, 0, pi over 4, and pi over 2. But our new points will be stretched by a factor of 3. I'm going to take all of these and just multiply them by 3. Like 3 over 1. So it becomes negative 3 pi over 2, negative 3 pi over 4, 0, 3 pi over 4, and 3 pi over 2. And now you have everything you need, Negative 3 pi over 2, 3 pi over 4, negative, 3 pi over 4 positive, 3 pi over 2 positive. Asymptote, asymptote.
Is that thing just like on the outer, the last one?
The asymptote? Yep, it's always going to be on the outside because that's what we decided to do instead of have it like be in the middle of it. Because it just made it a little bit easier. We got to have a smooth curve.
Do you need to always have one?
Yes. Here we go up one, and we go down one, there and there, and here's your curve. Oh, that was a good one. Okay. You will see word problems on tonight's homework, but they are not tangent related. It's a lot harder to think of real world situations that are modeled with tangent. It's much easier to think of like tides and Ferris wheels and things like that are sinusoidal. All right, cool.